We're back with yet another problem from chapter 8 from the review questions. So here we go. I'm going to also read through, this is problem number 5 from chapter 8. So here is the problem itself. It says a student performs the following reaction. She starts with 500 grams of calcium carbonate and an excess of iron phosphate. If she ends up with a 91% yield, 91.1% yield, how many grams of calcium phosphate did she end up making? Let's go ahead and work through that. This is kind of the reverse of what we did in problem 4. So this time, they're giving us an amount of calcium carbonate that she's starting with, but then they're asking you about an amount of calcium phosphate that she made. Okay, so let that kind of get in your head, right? We're given information about calcium carbonate, but we're being asked about the actual yield of a different substance. So what do we know immediately? We know that we're going to have to use stoichiometry, because if they give me information about one substance and then they ask me for something about a different substance, I know immediately I have to use stoichiometry because that's the only way that I can relate different substances, okay? So in order to get the actual yield, what information do I need to have? Well, I need to know the percent yield. Oh, look, they've given me that. And I need to know then the theoretical yield. Okay, I don't have that. But I have information about calcium carbonate. Okay, so let's go over here and look at our equation. Again, we're going to be isolating the variable differently than we did in the previous equation, but our equation is still the same. Percent yield equals actual yield divided by theoretical yield times 100%. Now, if reading it all like that looks a little bit confusing to you, feel free to just make those things be variables. X equals y divided by z times 100%. In this equation, we're actually solving for y. To find y, I've got to take x, multiply it by z, divide by 100%. That's mathematically what we're going to do. But we have to have theoretical yield, which we don't have. We have actual yield, and I'm trying to find the actual yield. We have percent yield. We don't have theoretical yield. We're trying to find the actual yield. So how do we do that? Well, again, they've given me information about calcium carbonate. So if I know how much I'm starting with, I can determine how much calcium phosphate I should end up with. So let's walk through the steps of doing that. Okay, again, 500.0 grams of calcium carbonate. Okay, from the last problem, I know that 1 mole of calcium carbonate is 100.09 grams of calcium carbonate. So 1 mole is 100.09 grams of calcium carbonate. So this tells me that I end up with 4.996 moles of calcium carbonate. Okay? Now I've got to relate moles of calcium carbonate to moles of calcium phosphate. And how do I do that? I do that by looking at the balanced chemical reaction. And I can see that I'm going to start with, for every 3 moles of calcium carbonate that I start with, I only produce 1 mole of calcium phosphate. So let's go ahead and do that. I have 4.996 moles of calcium carbonate. And I know that the relationship is that for every 3 moles of calcium carbonate, I only produce 1 mole of calcium phosphate. Okay, so when I do that, I'm going to end up with 1.665 moles of calcium phosphate. All right, that's the second step. And then, if I have moles of calcium phosphate, I can easily, using the molar mass, which I have written down here, which hopefully you'll be able to do very easily now. If that's still a struggle for you, you're not sure how I got a molar mass of calcium phosphate, you certainly need to reach out to me and let me know. Okay, but I know that 1 mole of calcium phosphate is 310 grams, but I don't have 1 mole. I have 1.665 moles, so how much does that translate into? Well, let's calculate it and see. I know that for every 1 mole, I've got 310.18 grams. And that ends up being 516.4 grams of calcium phosphate. Now, again, what does that number represent? I started with a certain amount of calcium carbonate. I've determined through calculations an amount that of a different substance. What do we call that? Well, we call this our theoretical yield. Okay? And now that I have theoretical yield, boom, and I've got a percent yield, they gave me that to start with, I can solve for actual yield. And I will do that by taking my percent yield, multiplying it by my theoretical yield, and dividing by 100%. Let's do that. Okay, so I've got a percent yield, so my actual yield is going to be my percent yield, which is 91.1%, times my theoretical yield, that's what I just came up with. That's 516.4 grams, divided by 100%. And when I do that, I get 470 grams of calcium phosphate. However, I have 3 sig figs. So how do I write that so that it has 3 sig figs? I would simply write 4.70 times 10 squared grams of calcium phosphate. And that would be my final answer. Now, one thing you just want to make sure that you understand, when you're talking about these yields, that's my final answer right there. When I'm talking about these yields up here in my percent yield formula, actual yield is gained through experimentation. Okay? It's an amount that you actually have, you actually gain through some kind of procedure. Your theoretical net yield is always determined through calculations. So that's how you can kind of differentiate between the two. So hopefully that helps. That's the answer to number 5, and we'll talk to you soon.